So replica management with perspective to the content distribution. There are three different trade-offs that we can see in the content distribution. That is the state versus operations, pull versus push protocols, unicasting versus multicasting way of message communication. So based on these three topics, we will be discussing content distribution with respect to replica management. So the first trade-off is the state versus operations. So in this case, how is the actual data or actual update is propagated to various replicas? So there are three possibilities of indicating that there is a update happen. So one is you notify the replications that there is some updation happen. So you will be just propagating the notification of an update. And in the second case, you are just transferring one copy of data to another. And in the third, you are going to propagate only the operations which are done on the copies. You are not going to transfer any type of messages. So you are just communicating. These are the operations done, and you will be having the updated copy after performing the set of operations. So they are the different ways of sending the or propagating the updations happened at one part of one replica. So in the first category, that is propagating a notification. In propagating the notification, it is basically taken care by invalidation protocols. So in the invalidation protocols, it actually informs that an update has taken place, and the data which you now have is no longer valid for the operations. So that is how it is invalidated. Like you will be just sending the notification that there has been update happened. So the data which now you have in your hand is no longer valid data. So the main advantage of this kind of just sending the notification is this type of notification will take a little network bandwidth. Right, you are not going to transfer the entire data, right? You are just going to notify that there has been some updations done, right? So such protocols will be working perfectly when the read to write ratio is small. Read to write ratio is relatively small. Okay, so that means you will be having more number of write operations, right? When there is more number of updates happening, you are not going to send the each and every updates data, right? So you will be just performing the you will be just notifying that there has been some updation happening. So that notification is done. Then the proper updations has to be taken care. Right, so that is about the invalidation protocols. Now, the second case is the transfer data from one copy to another. Right, so that's a second alternative to keep the what do you call it, the propagations, right, in track. So in this category, transferring the data from one copy to another, the second alternative. So this will be more useful when read to write ratio is high. So what is it? You have to actually transfer one data, make a copy of the data to another copy, right? So think of the situation where there are more number of writes. So frequently you have to transfer the whole data itself. If the data is small, again, it is kind of an overhead. If assume that the data is very big, consumes more energy, more memory, then every time when the write operation is happening, you have to transfer the data. So this kind of data replication process will be helpful when read to write ratio is high. That means the read operations are more compared to the write operation. So in that situation, transferring the data itself will be that second alternative for keeping the replicas consistent will be useful. So in this case, you can see that the update will be the probability that an update will be effective is when the updates are taking place. I mean, the read operations are more compared to the write operations. So that's about the second category. In the third category, it is actually you are going to indicate that these operations are performed. You are not going to notify about the updates. Instead, you are going to tell that these are the sets of operations done, right? So that particular operations alone need to be propagated. You are not going to propagate the actual data itself. So it is not transfer any data modifications, but it actually tells these are the update operations performed. So this kind of update operation, propagating the update operation alone is called as active replication. So this assumes that each replica is having a process capable of keeping the data up to date by just performing the operation. So if I am performing, so in one replica, I am performing some set of operations, say R1. So that operations, update operations is now propagated to all the other replicas, R2, R3, etc. So they will be R2 and R3 will receive these operations which are done on replica R1, and R2 will execute the set of operations which was already completed on R1, and R2 and R3 will be doing that operation, and thus the consistency of the replica is managed. So this type of propagating the operations alone is called as active replications. So this will also consume minimal bandwidth, right? Provided the parameter that you need to use is having very less memory usage. Okay, so in this case, it consumes. In the second case, it may consume high bandwidth based on the data size that you may have to transfer. So these are about the state versus operations. So three types of replica content distribution here. You will be notifying about the update. You will be transferring the data from one part to another, or you will be propagating the operations alone. So based on this, there are three different ways of doing the state versus operations. So the next is about the second way of performing, that is, you would have seen pull versus push protocols. So that's the second case, pull versus push protocols. Okay, so in this case, so how the data or update is being propagated. So in case of the push-based protocol, so it is basically a server initiated, as we have seen in the server placing schemes. There are so this will be more suitable for permanent replicas and server initiated replica management. Okay, so server initiated replica. So these push protocols will be more suitable for this permanent and this thing server initiated. In case of pull, it is basically a client initiated replica. It will be more suitable for client initiated replica. Okay, so now in this case, we will see what is the difference between the push based protocols and the pull protocols. So when in order to to maintain a strong consistent data, strong consistent means all the replicas are having the same update same copy and they are they are consistent with each other, right? So as I told, the push protocols are mainly used for the permanent and server initiated protocols, right? Or server initiated replicas. So here the read to update ratio at each replica is relatively high. So in that case, we will be using, so in read to update ratio is high, in the sense that the read operations are more compared to the update operations. So in that case, the push protocol is going to be used. So this push protocols, how or what they will be doing is that once the update has been done, the server will push the informations to all the caches, right? So these caches are kept updated without even a request coming from the any of the client. Server is going to push the updates which it has received. So this kind of push protocol based replica management will be more useful when the system itself is having read to update ratio is high. So coming to pull based approach. So here it is basically a client based protocol, that is client initiated protocol. So here the common strategies, web caches is so you will be having a cached data, right? So the example discussed is with respect to the web caches. So you will store the informations for improving the performance of the response time. The data is stored in the cache, and when you make a frequent request for the item, if it is locally available in the cache, that particular data is given back as a response, right? So now in the case of, say, suppose a modification is happening, thus the modified data transferred to the cache, right? So the cache will be checking, the cache checks with the server whether there was any update happened. So now web cache communicates with the server to check if there is any update from the last storage, right? To check for any update. Okay, so if so that is cross-checked with the original web server, right? If in this case, if there is a modification, then modified data is to be transferred to the cache, right? So here server if indicates that there is a modification, then this modified data is passed to the server back, right, or the cache. So this is a modified data or updated data. So this updated modified data is now reaching the web cache, and from the web cache it goes to the client which requested for the web page, right? So that is the way the pull based protocol is working. So the example discussed here is with respect to the web cache. So web cache stores the recently visited page history, and when you are querying the same web page again, the web cache from it is retrieved from the web cache, right? So in order to keep the updates in order to keep track of the modification of the web page, what this web cache is going to do is it will communicate to the original server to check if there is any update. So if the server finds any update, it sends a modified data to the web cache, and from the web cache, it returns the requested page to the client. So in other words, here in the with respect to pull based approach, this is actually client has to poll whether there is an update. So the client polls the servers to see whether an update is needed or not. Okay, whereas in push based protocol, the server is actually responding when it finds any update, the server is going to send that update to the uh, all the communicating clients. So in case of a pull based approach, it is efficient when you can see the read to update ratio is low. Read to update ratio is low. So the main drawback with compared to the push based is the time response time is increasing when there is a cache miss happens in case of the pull protocols. Okay, so that is about the second trade-off, the pull versus the pull versus the push protocols, which is explained here with respect to the aspects of state at the server, message send, and response time at the client. So here you can see it is for push-based protocols with respect to state at the server, and pull-based protocol with respect to the state at the server. In push-based protocol, server, so the list of client replicas and caches, right? So the server has to push all the updates to the client replicas to which this particular servers are getting connected to, right? So that list of the clients has to be maintained at the server. So if there is any update happening at the data part to which this client is now accessing, they have to send these updates, right? So server will need to know the list of clients which are holding the copy of the data to which this server is connected. So when there is any update happening, the server is going to send all the updates to the list of client to which it is which it is connected to. In case of pull based, so pull based, as we told, it is a client centric based. So state of the server is not going to change when there is any update. The client is going to invalidate, go check and come back, right? So the server does not keep any list or to communicate back if there is any update. So you can see it is none. Messages sent. So in case of messages sent, you can see the push based is update, and it possibly fetch updates later. So it communicates server and sends update to each client, right? In push based protocol. As a list of clients are maintained, so the push-based protocols will send the updates to all the clients to which it is connected, and it invalidates the content, modified data, and make it consistent. In case of client-based, we know that it is a poll-based, so client communicates to the server to check if there is any update happened, right? So if there is any update happened, then it takes that modified data to the replicas. So it is a poll based. So the client polls the server, is there any update, right? So based on that, if there is an update, corresponding decisions are taken. Response time. So the response time at the clients is immediate, right? So this is with respect to the client. So it is immediate. So as soon as there is an update happening at the server, it is being communicated to the clients connected to that server. And in case of pull based, it is fetch update. As you know here, the client has to poll and check if there is any update. So it is kind of a fetch update time. So you have the client will fetch if there is any update is happening, and then updates the informations. So that is about the pull versus push protocols for content replication. So now based on these update propagations, in case of replica management, how or on what basis the server has to keep the updates properly. So that is being decided based on the lease, the concept of lease. So here a lease is a kind of a promise by the server that it will push updates to the client for a specified time. So it is a kind of an agreement, right? You know more about the lease kind of system. So it is a promise, so which is done by the server. So server promises the client. Server promises the client that it will push updates to the client for a specified time. Server promises client that it will push updates for a specified time. Okay, so that is what a kind of a lease is to, in order to make the content or the updates propagated to different replicas. A lease kind of setup is designed, where the lease is a server, it's a promise which server gives the client that it will keep the data or it will push the updates to the client for a specified amount of time. Okay, so when the lease expires, the client is then the client is forced to poll the server for updates and pulls the modified data if necessary. So till then it will be acting as a push based protocol, right? So dynamically with respect to these lease, the behavior can be either a push protocol based or pull protocol. So till the lease has not been expired, it will behave as a push protocol. So that is a promise made by the server. So whenever some updates happen, the server pushes the updates to the client. But once the lease time is over or lease has been expired, then the client has to take care about the updates. So the client polls the server and checks if there is an update, and it takes the update. It takes the updates if it is necessary for that part. Okay, so that's about the lease based. With respect to this lease based, there are three types of leases that has been discussed. So first one is age based. So right on the next page. So first is age based leases. Second you have is renewal frequency based lease. Third one is state based lease strategies. Okay, so as we have seen, what is a lease? Based on the lease, the active and if the lease is active or not expired, then it will behave as a push based protocol where server will send the updates to the client. Once the lease has been expired, the client has to poll if there is any modification to the server. So after which it behaves as a pull based protocols. So there are three different types of leases with respect to the what type of data that you may have to keep update. So that they are age-based leases, renewal frequency-based leases, and state-based leases. In case of age-based leases, so this particular lease is with respect to when was the last modification happened to that particular data for which you want to start a lease. Okay, so you have a data item. So when was this particular data item last modified? Okay, based on that, this lease has been functioning. So what is the assumption here is that the data which is not modified for long time, right? So that is not going to be modified for some time yet to come, right? So that is the assumption. For long time, some particular, so important assumption in case of age-based leases is the data which is not modified for long time. So this particular data is not modified for long time, then it is expected not to be modified for some more time yet to come, right? So that is the assumption. So if so that's going to be kind of a static data, right? That is not going to change for some more time yet to come. So that is assumption. For those kind of data, age-based leases will be more suitable because you need not go and kind of check, right? So these data is not going to modify for a long time, right? So then server is kind of free, right? So when you put leases for those kind of data as a age-based leases, server need not push the modifications frequently to the clients because this data is not going to be modified for a longer amount of time. So by granting the long-lasting leases to the data items which are expected not to be modified frequently or remain unmodified for a long time, so this kind of leases will be more suitable for those kind of data. So the next is with renewal frequency based lease. So in this category, so the client, a specific client, requests its cache copy to be updated, right? So in that case, it is a renewal based. So with renewal based frequency, renewal frequency based leases, server will hand out a long lasting lease to a client, okay, whose cache often needs to be refreshed. Okay, so the cache of the client is need to be refreshed very minimal amount of time. Then this kind of leases will be useful. So if the client asks occasionally, right, frequently it is asking for the data to be refreshed, right? So it will be given a short-term lease for those items. So the effect of this kind of strategy is that server keeps tracks that the client is whether the data is consistent or not, right? So this offers a high degree of consistency. Okay, so that is about the renewal frequency based leases. Now coming to the state based leases. So in this case, a server needs to keep track of fewer clients as leases expire more quickly. So it is with respect to the with respect to the how the server is overloaded or there is an state space overhead at the server, right? So the server has to keep track of the list of the clients with the type of the leases offered to them, right? So if the server is becoming kind of overloaded, this type of leases will be more useful. So this kind of leases will expire more quickly so that it need not keep track of the uh, more number of clients. Assume that say the more number of so the leases are there and the n number of clients are this server has to keep track, right? So that means the push protocols. So whenever there is an update is happening, the server has to send updates to all the end clients. So this is going to increase the overhead of the the server state, right? So what happens at this time is the server will provide very less amount of time to expire the leases. So what happens is this kind of leases is like, so they expire, lease expire more quickly. So if the lease expires more quickly, what happens? The server needs to keep track of very less number of clients, right? It need not keep track of all the end clients because the leases are going to expire more quicker, and the clients that server need to keep track will go down. So this will reduce the overhead of the server. So that's the idea of state-based leases. So that is about the push and push and push and pull based protocols. Now the last trade-off is with respect to the type of the communication, right? So that is unicasting versus multicasting. So related to this, how is the communication between the clients and servers need to be done? In case of unicast, so the server has to contact the other server, right? In case of multicast, it is a kind of a group communication. So if it is in unicast and it is connected to n different servers, n communications in separate messages has to be sent, right? So in this case of multicasting, so the underlying network is going to take care about the type of the message, the messages being efficiently delivered to the other receivers, right? Multiple receivers will be getting that. So when to use what kind of communication is the trade-off that we are discussing here. So if you have an available multicasting facility in the network or in your distributed system to manage the replica, then that's a cheaper solution. And so in case of say broadcasting or multicasting messages, so there is very less expensive compared to the single point-to-point communication that you may have to establish to make the replicas consistent, right? So that is about the multicasting and unicasting. So in case of multicasting, it is more combined with the push-based approach to propagate the updates. Okay, so you have so based on the distributed system or how the replica management is designed, the decision of what type of communication is more suitable can be decided. So which is the trade-off of unicasting versus multicasting.